So we can extend our table just a little bit further, and we can plot as many points as we want to get a more exact picture. But let's start by looking at pi over 4 radians, which is 45 degrees. And we can go from there. We can also look at essentially the 45-degree angle over here, which would be 135, which would be 3 pi over 4 radians. We can look at the angle value down here, which would be 5 pi over 4 radians, or 225 degrees. And we can look at this value here. And we'll just focus on the positive angles since it'll be a similar pattern in the negative angles. And this angle right here would be 315 degrees, or 7 pi over 4 radians, though it would be the same as negative 45 degrees or negative pi over 4. And a pi over 4 radian angle, or a 45-degree angle, allows us to construct a right triangle. Let's just focus on the first quadrant, but it'll be similar for all the other quadrants, where we have this triangle that is a 45, 45, 90 right triangle. We know the hypotenuse is 1, and we can use the Pythagorean theorem. Since we know each of these side lengths are the same, we can call them each x, set up that Pythagorean theorem, and solve for that. Or we can remember the pattern that the small sides, when multiplied by the square root of 2, give us the hypotenuse. Or in reverse, when we take the hypotenuse, we can divide it by the square root of 2 to find the smaller sides. And when we rationalize this, when we multiply top and bottom by the square root of 2, we just get the square root of 2 over 2. And if we evaluate the sine of 45 degrees, or pi over 4 radians, we're looking at the opposite side divided by the hypotenuse, but we're dividing by 1, so this is just the square root of 2 over 2. And if we evaluate this on a calculator, it's about 0.07. It is an irrational number because of the square root, but this will give us a rough idea of where this point is on the graph. So the sine function at this angle is the square root of 2 divided by 2. And when we look at that point, essentially here on the unit circle, we would also be able to construct a right triangle with the same angles, so therefore it would have the same height. It would be at root 2 over 2 for that y value as well. But when we construct that triangle down here, it would still have the same lengths, but now we're going in the negative direction for the y value. So this would be minus root 2 over 2. And when we're over here, we would construct that same right triangle, but again, the length downward would be negative. It would still be root 2 over 2, but it's in the negative direction. So the sine of 7 pi over 4 radians, or 315 degrees, would also be minus root 2 over 2. And if we want, like I mentioned, we could also look at other values. We can look at pi over 6 radians, which is 30 degrees, and we would be able to construct a 30, 60, 90 right triangle and determine that this is 1/2. We can look at pi over 3, which is 60 degrees, and see that this would be the square root of 3 over 2. But this should give us a rough idea of the curviness of this function. So let's plot each of these points, assuming that this root 2 over 2 is approximately 0.7 or so. And for instance, this would be at pi over 4, right in the middle of this interval. And it would be roughly 70% up. So probably somewhere right about there. And again, we can do the same thing halfway in between this interval. This would be 3 pi over 4, which would be at that same y value. And we go down here, but now it would be about 70% down. And again, halfway between, that is the 5 pi over 4. radian, that would be right about there. And at 7 pi over 4 radians, we would be right about there. And so we can start to see some of the curviness of this function, though that's not drawn perfectly. And like I mentioned, if we want, we can also look at these angles right here. Since at pi over 6 radians, that would be a third of the way over, we would be at right about 1/2, so somewhere in here. It's hard to draw this perfectly by hand, but you can get a rough idea of how this should work. And likewise, if we continue this analysis, but now looking at the negatives, then these first two would be negatives, and these last two would be positives, and we can plot those points over there, since ultimately all of those are based on this special right triangle. And I will, at this point, fill in the curve so that we can get an idea of what this function actually looks like. And what we can see is that the sine function is indeed this wave. Though if you want to get a perfect picture of this, you can of course use a computer or a graphing calculator to plot all the points for you and draw yourself a picture.